Hi dear students, this is the last presentation from the first module of the subject Advanced Energy Engineering. In this presentation we will be discussing about the nuclear power plants. Okay, as we know, nuclear power plants are the cheapest means of producing energy, but having a lot of safety issues. That's why it is not commonly used, because if the radiations are released, then it will be dangerous to the human being. So a lot of safety issues are there, and also waste disposal of the nuclear power production is also a big headache for the human being. So that's why these are not popularly used, but still most of the countries are producing a lot of energy from the nuclear power plants, especially in India also, like in Tamil Nadu and all, nuclear power plants are there. In nuclear power plant, heat energy available from nuclear fission reaction. See, it is fission reaction, that is controlled. Fusion reaction is known as fission reaction. Heat energy available from nuclear fission is used for the generation of the steam. So by the nuclear fission reaction, what happens is energy is released on breaking of the molecules, or the energy is released, very high heat energy is released. That heat energy is used to produce the steam, and using that steam turbine is rotated and power is produced. So incorporating with the nuclear power plant, always there will be steam power plant also. The steam generator also will be there. So as a combination, nuclear reactor plus steam turbine will constitute the nuclear power plant. In nuclear power plants, neutrons collide with uranium atoms, splitting them. Initially the neutrons are with very high velocities colliding with the uranium atoms, and this collision causes for the splitting of the uranium atoms, and it releases energy in the form of electromagnetic radiation. See, it is releasing very high electromagnetic radiation, that is heat energy is released, and along with that kinetic energy is also released. This split releases neutrons from the uranium. So once this neutrons are colliding, free bombarded neutrons are colliding with the uranium atoms, the uranium atom is split into two, and further on splitting, the uranium atom further releases the neutron, which in turn is further colliding with the remaining uranium atom. So in that way the fission reaction is processing. So the initially we will have the neutron atom to initiate the reaction. So that neutron colliding with the uranium atom will split the uranium atom into two. On splitting process, the uranium atom releases further neutrons, which in turn is colliding with the another uranium atom. So it goes on like a chain, so causing chain reaction. This chain reaction is controlled with, but actually this reaction is to be controlled for the power production, otherwise the heat energy produced or the radiation produced will be very high. So fission reaction means actually controlled fusion reaction. So we must be able to control the reaction. So excess neutrons is produced during this breaking of the uranium atom, is some amount of neutron is to be absorbed by some materials, so that the whatever neutron is required for the further reaction only is released. So actually it is a controlled chain reaction, we can say. Fission is a controlled chain reaction, and due to that controlled chain reaction, a lot of thermal radiation is, or heat energy is produced, electromagnetic radiation is produced. That heat energy is used to heat the water in a heat exchanger. So the water is converted into very high pressurized vapor, which in turn is running the steam turbine. The heat produced by fission in the nuclear reactor is carried out of the reactor by the coolant. So some coolant will be there to carry the heat energy from the reactor. So this coolant will be coming in contact with the, not direct contact, in a separate heat exchanger outside the nuclear reactor. There will be a heat exchanger. So this coolant will be passing through that heat exchanger in one direction. To the opposite direction, the water will be flowing. So heat energy from this coolant is absorbed by the water to convert its phase into vapor state, and that steam is utilized to produce the power. This heat is used to generate the steam. This heat transfer takes place in the heat exchanger such as steam generator. The pressurized steam is then fed to the steam turbine, which is connected to the generator. So this pressurized steam from the heat exchanger is then fed to the steam turbine, which in turn is connected to the generator. So the electricity is produced. This is a simplified sketch of the nuclear reactor, comprising all the nuclear reactor plus steam turbine. You can see here, you can see this here you can see this entire portion is the nuclear reactor, and this portion is the steam turbine. This is the steam turbine portion, and in between you can see steam generator also. Okay, so here in the nuclear reactor, the major components are control load will be the moderator and fuel rod. Fuel rod is actually not shown here. You can see this portion is the fuel. This is the fuel rod. These three is the fuel rod, and this one is the control rod, and this one is the moderator. Actually, the moderator is this hatched line at the left extreme end here. Here, 4 moderators you can see. The function of the moderator is to control the fission reaction, and fuel rod, of course, whatever nuclear fuel is used, mainly uranium is the, in most of the cases we will be using uranium as the fuel, so uranium rods will be there as the fuel rod, and above that fuel rod you can see the control rods. Control rods are to control the chain reaction. Okay, moderators are to absorb the excess neutrons produced during the fission reaction of the uranium atoms. Okay, so I have already told we have to somehow control the reaction, so excess neutrons produced is being absorbed by the moderator. That is what is happening. Anyway, we will be discussing the components of the nuclear reactor in the upcoming slides. So actually what happens inside the nuclear reactor is, due to the fission reaction, the neutrons will collide with the uranium atom, and as a result the uranium atom will split into further neutrons. So that along with that release of the neutron, some electromagnetic radiation is released which having very high heat. So that heat energy is utilized by the coolant inside the nuclear reactor. So coolant will be absorbing the heat from the nuclear reaction inside the nuclear reaction, and you can see that hot coolant will be circulated from the nuclear reactor through this line, and it is passed through the steam generator. You can see the steam generator. So this hot coolant is passing through the steam generator, through the one pipe of the heat exchanger of the steam generator. Through the other pipe the water will be flowing. You can see the feed pump, water will be flowing in the opposite direction. So the heat energy from the hot coolant is absorbed by the heat water, so it changes its phase into high pressure steam. That steam is fed to the steam turbine. So the generator is connected to the output of the steam turbine, so the power is produced. That power is utilized for producing the electricity. So from the generator electricity is being produced. After expansion, the steam is passed through the condenser, where it is condensed by the, again heat exchanger will be there to condense the steam. External water also will be circulating, cold water will be circulating through the condenser. So the heat energy is lost to that coolant. So further condensed water is again circulated using a pump as a circuit. You can see continuously water is being pumped. Okay, so after giving the heat to the water, the coolant will be again circulated into the nuclear reactor. So that is what is working of the nuclear reactor, nuclear power plant. Okay, I think the concept is clear for you. In the upcoming slides we will be discussing about, okay, one more thing I had to add is there should be a strong shield outside the nuclear reactor to prevent the radiation to the atmosphere. So that is added to the safety precautions. So there should be a strong shielding. Okay, so pressure vessel is also there, where the heat carrying everything is happening inside the pressure vessel. Anyway, we will be discussing the components in detail. At that time we will be discussing about the components of the nuclear reactor separately. So coming to the components of the nuclear power plant, the main or major components are these 4 are the major components. First one is nuclear reactor. So that entire thing happening inside the nuclear. It is an apparatus in which nuclear fuel is subjected to nuclear fission. So nuclear fuel is subjected to nuclear fission. Due to that nuclear fission, energy is produced. That is what is happening inside the nuclear reactor. That heat energy is carried by the coolant to outside the nuclear reactor. So then comes the important component, heat exchanger. I have already told the coolant is exchanging heat to the normal water out in the heat exchanger. So heat exchanger is the next main component. The coolant gives up the heat to the heat exchanger, which utilizes for generating steam. After giving up heat, the coolant is fed back to the reactor. So coolant is, after giving heat, it is circulated back to the heat exchanger, back to the nuclear reactor. Then comes the third component, that is steam turbine, which is used to expansion of the steam inside the turbine will produce the work output. And the last one is generator. Of course, generator is used to produce the electricity that is coupled to the shaft of the steam turbine. These 4 is the main components. So coming in detail to the subcomponents of the first one, that is nuclear reactor. Components of the nuclear reactors are, first one, fuel. Fuel is the main component, as I have already told. Sorry, this figure we can refer. Here you can see. Here this is the fuel rods. This one is fuel rod. This one is fuel rod. This one also is fuel rod. These are the fuel rods inside the nuclear reactor. Nuclear fuels usually used in the reactors are isotopes uh, isotopes of uranium and plutonium. What is isotope? Isotope is atoms of the same element having same number of protons but different number of neutrons. That is what is known as the isotope. So usually the nuclear fuel used is isotopes of uranium and plutonium. So isotope like uranium 233, uranium 235 and plutonium 239 can be fissioned by neutrons of all energies. So all energy neutrons can be utilized for the fission reaction of these three elements, these three fuels. But in case of uranium 238 and thorium 232 and plutonium 240, these three are fissionable by only high energy neutrons only. So in this case, if we are using these three as the fuels, then we have to use the high energy and neutrons for the chemical reaction, for the fission reaction. So that is very difficult. So usually the uranium 235 is commonly used as the fuel. Usually pellets of the fissionable material are arranged in tubes to form the fuel rods. Pellets of the fissionable elements, that is uranium 235 is kept here, you can see in the figure. It is usually arranged in a tube form. Okay, powdered uranium 235 is arranged in a tube form, so that the neutrons, once it collides with the outer atom of the that cylinder or cylindrical arrangement, what happens is whatever neutron is colliding with the uranium will split into two. So further neutron is released. That neutron further collides with the again uranium atom. So that neutron will be moving in every direction inside the reactor. So the neutrons colliding in the moderator, most of the neutron colliding with the moderator is absorbed there itself. That is the function of the moderator. And you can see outer side, you can see the reflector also. Actually, this is the moderator rods. So the main function of the moderator is to absorb the neutrons produced during the fission reaction, so that only very few neutron is allowed to further fission reaction. So in that way we can control the fission reaction. Okay. So now comes moderator. Moderator is used to slow down the kinetic energy of the fast moving neutrons. See, the moderator is absorbing the kinetic energy of the fast moving neutrons. As I have already told, in the if uranium 235 is used as the fission fuel, then a slow moving neutron is used as the energy producing agent. For the fission reaction, slow moving neutron is required. So the kinetic energy of the neutron produced after the fission reaction is to be reduced. Moderator is actually doing that function. The moderator is used to slow down the kinetic energy of the fast moving neutrons. This has to be done as only the slow neutrons maintain the fission state reaction. The neutrons collide directly with the moderator and thus slowed down. Substances like light water, heavy water, carbon rod, this is commonly used. Carbon rod is commonly used as the moderator. Beryllium are used as the moderator. These are the four components commonly used. Out of that, carbon is mainly used. Now comes the control rod. Control rods are used to control the nuclear chain reaction. It is the essential part of the reactor and serves the following purposes. The first one is for starting of the reactors, for maintaining at that level, and for shutting the reactor down under normal or emergency conditions. Control rods are usually made up of cadmium and carbon. Control rods control the chain reaction by absorbing the neutrons. Actually, in the initial part I have explained moderator. Actually, moderator is not absorbing the neutrons. Actually, the excess neutrons are absorbed by the control rods. So control rods are made of cadmium and carbon. So the excess neutrons produced during the fission reaction is absorbed by the control rods, and the function of the moderator is just to slow down the pace of the neutrons produced during the fission reaction, so that the next reaction will take place. Okay, so that is the functions of the moderator. We have explained control rods, we have explained fuel rod also we have. That is three major components. So inside this outside this we can have at the outermost we are having a shielding. That the purpose of the shielding is to prevent the radiation to escape into the atmosphere. That is the function of this shielding. And inside the shielding you can see reflector is there. Inside the shielding we are having pressure vessel, and inner to that pressure vessel we will be having the reflector. The function of the reflector is same as that of the moderator, just to slow down the pace of the neutron. So sometimes after reaction neutrons will be moving in any direction. So either it will be colliding with the moderator, or sometimes it will be colliding with the reflectors. So once it collides with the reflector, then also its kinetic energy is being reduced. Now coming to the next one, coolant. Coolant is actually situated inside that space, inner space, covering all the fuel rod, everything. We will have the coolant. So whatever heat is produced by the heat fission reaction is absorbed by the coolant, and through a particular duct it will be carried to the outside of the reactor. Then it is passing through the heat exchanger to give away the heat. Then finally it is circulated back into the reactor. So purpose of coolant is to extract the heat generated by the fission process. The various fluids used as the coolant are water, light water or heavy water, gas. If it is gas, air, CO2, hydrogen, and liquid metal cooled reactors are. All these are commonly used coolants. So the purpose of the coolant is to carry the heat produced by the fission reaction inside the reactor to outside the reactor, and finally passing through the heat exchanger, it is giving it to the it is given to the water. So that steam is produced and is back circulated back. After giving away heat, the cold coolant is circulated back to the reactor. So just heat energy produced inside the reactor is carried by the coolant to the to outside the reactor. Okay, that is the function of the coolant. Now coming to the reactor vessel. It is a strong walled container housing the reactor called shield and the reflector. It is strongly built. So as to withstand high pressure developed. That is the nuclear vessel. Actually, it is the shielding from the nuclear radiation. Then comes the reflector. Inner part is reflector. Reflector is used to reduce the loss of neutron by reflecting back into the core of the nuclear reactor. Reflector is generally made of the same material as that of the moderator. See, both are serving the same, but moderator and reflector is having the almost the same function. So reflector will make sure that no neutron is escaped from the reactor. So everything is reflected back into the reactor itself. Shield. The shield prevents the transfer of radiation to the external world. That is the function of the shield. The outermost shield is to prevent the escape of radiation to the atmospheric air. So there are important two classification for the nuclear reactors. That is, one is pressurized water reactor and the second one is boiling water reactor. These are the two important classification of the nuclear reactors. I am giving you it as an assignment too. Please do it as an assignment. I will tell you the date of submission also. So anyway, prepare these two. This is the major classification, and you just go through what is the difference between these two also. So then you will have an idea about what is pressurized water. Okay. Now coming to the advantages of nuclear power plant. No problem of fuel transportation, storage, etc. That is the main advantage. Less manpower is required. It is more economical, but less manpower. Of course, less manpower, but very much technical knowledge is required for that person operating this one. It is more economical compared to thermal plant. Power capacity of plant is very high. Capacity cost except for reactor is very less. See, cost of reactor is actually very high, but total cost is less. It does not depend on the condition of the weather. Whatever condition of the weather it is, it will work. By this process, we can conserve the fuel like oil, coal, gas, and other byproducts. See, this is the main advantage. We can cut down the other fuel consumption, but only problem is with the nuclear radiation produced by the nuclear reactor, and if any accidents happens, it will be affecting the people in that entire area. So that is the main problem. Coming to the disadvantages, nuclear reaction causes severe environmental problems. See, if it is working properly, then no issues. Once accident happens, it is a major severe environmental problem. So disposal of radioactive nuclear waste is a menace. So it is a big problem, disposal of the radioactive. And right now, I think buried inside the sea and all at a very high depth. That is what is usually followed, but that also is not a permanent solution. It is also having its own problems. See, radiation can escape through the sand and all after a long time also. So gradually it is having some effect. Varying load conditions are not suitable. Controlling of the fission reaction depending on the load is very difficult. So usually it is set for a particular pace and all. So in that manner only it will work. So depending on the load, we cannot vary the power production. Capital cost is very high for the reactor. So that are all the disadvantages. With this presentation, the first module is over, and you please do the assignment I have given along with this presentation. Anyway, thank you. In the next presentation, we will be starting the second module. Okay.